Welcome to Lanex Mesh Tutoring. Today we'll be covering geometric patterns. We'll firstly cover the concepts and then thereafter we'll do examples to reinforce the knowledge. Furthermore, there's a quiz at the end of this video that can be used to assess your knowledge and understanding of this topic. Let's get started. Alright, so let's get started with geometric patterns. Alright, so the first thing first that we need to do is establish the general term for a geometric pattern, which can be given with the following formula. So the general term equals to Tn equals to A R n minus 1, right? And so what we know is that A is our first term, and then R is what we know as the common ratio or constant ratio, common ratio. Alright, so how do we actually get our common ratio? Alright, so common ratio formula is as follows. R equals to Tn plus 1 divided by Tn, right? So this is the formula for getting our common ratio, right? And something to take note of is that when common ratio is greater than 1, it means that you have an increasing geometric pattern. Increasing geometric pattern. And when you have your common ratio being in between -1 and 1, then you have a decreasing geometric pattern. Alright, so in order for us to get the next term, we just need to rearrange the common ratio formula. So we're going to have Tn plus 1 being equals to Tn multiplied by R. Alright, great. And so in order for us to determine whether we're a geometric pattern or not, there's a certain formula that we can use to actually check that. So it is as follows. So a geometric pattern is only a geometric pattern if this equation holds. So you have T3 divided by T2 being equals to T2 divided by T1. So this is the formula. So in order for us to have a geometric pattern, this formula needs to hold. So here's a toolbox that can help in terms of solving geometric patterns equations. So when they mention that find the general term, this means find A and R. So A we know is the first term and also your common ratio, not N, which is your number of terms. Which come to the next note, which is saying finding the number of terms means finding N, right? And then the other note is that when the two values of two terms are given, solve for A and R using simultaneous equations. So when you have the values of two terms, solve for your first term and also your common ratio. And thereafter you can use simultaneous equation to find the answer. Alright, so this is just a toolbox for solving geometric patterns. Alright, now that we have our toolbox ready, let's go ahead and solve the questions for geometric patterns. Alright, so here's the first question, and it reads, are the following sequences geometric? Give a reason for your answer. So this is 1A, we have 128, 64, 32, and so on. So before proceeding with this video, just pause, have an attempt at this question, and when you are sure of your answer, come back and see how it's actually approached. Alright, so let's go ahead and solve this question. So as I've highlighted, in order for us to determine whether we have a geometric pattern, we need to use this formula. So it would be T3 divided by T2 equals to T2 divided by T1, right? And here what we can see is that our third term is 32, so it would be 32 divided by our second term, which is 64. Then our second term, we know it's 64 divided by T1, which is 128, right? So we know that 32 into itself is 1, and then 64 is 2. So we have 1 over 2, right? So now we do see that these are actually equal, and therefore we know that for a common ratio, we do know that a common ratio is T2 over T1, which will give us 1 over 2, right? So using this reason, we know that this sequence is geometric. Following sequence is geometric. All right. All right. Now that we are done with question 1A, let's go to question 1B. So it reads: are the following sequences geometric? Give a reason for your answer, right? So the sequence that we have is 2x, 2x squared, and 2x to the power of 3, and so on. So now we need to determine whether it's a geometric sequence or not. All right, so we apply the same formula. So we're going to have T3, divided by T2 equals to T2 divided by T1. So the third term here, we know it's going to be 2x to the power of 3 divided by the second term, which is 2x squared plus 2. Then the second term is 2x squared divided by 2x, right? And we know that 2's will cancel out. X to the power of 3 divided by x2, it'll give you x. And then here, same, cancel out. X squared divided by x gives us x. Therefore, we know that our common ratio is going to be x, right? Therefore, we do have a geometric sequence, since we have a common ratio of x. All right, now that we're done with question 1B, let's go to the next question. So the next question, which is question 2, reads: find the value of the first three terms of the following sequence when the general term is Tn equals to 3 to the power of 2n minus 1. All right, so let's go ahead and solve it. So our first term, which is going to be T1, so it's going to be 3 to the power of 2, then n in this case is 1, so minus 1. So we're going to have 3, 2 times 1, it's going to give you 2 minus 1, this is 3 to the power of 1, which will give you 3. And then 2, second term will give you 3 to the power of 2 multiplied by 2 minus 1. So we have 3 to the 2 multiplied by 2, that's 4 minus 1. So we're going to have 3 to the power of 3, which is 27, right? And then our third term is just going to be 3 2, and then this will be 3 here, minus 1. So we're going to have 3, 2 times 3, that's 6, minus 1. We're going to have 3 to the power of 5, and this will give us 243, right? Therefore, our first 3 terms, we have 3, 3, second term is 27, then our third term is 243, and so on. Alright, now that we're done with question 2, let's go to the next question. Alright, so here's question 3. So it says, determine the general term of the following geometric sequence, which is 7, 21, 63, and so on. Right, so as we know, the general term is Tn equals to A, R, and minus 1, right? So first thing, we need to get the first term. So in this case, our first term equals to 7, right? Then we need to find our common ratio. So we know that for our common ratio, it's going to be T2 divided by T1. So that will be 21 divided by 7, which will give us what? 1 divided by 7, that will give us 3, right? Therefore our general term is going to be Tn equals to our A 7, and we know that our R is 3, so it's going to be 3 and minus 1. Alright, now that we're done with question 3, let's go to question 4. So question 4 reads, determine the first and eighth terms of the following geometric sequence, which is negative 6, 12, and negative 24. So remember to pause the video, and when you are sure of your answer, you can come back and proceed with the video. Alright, so first thing first, we need to find the general term of the geometric sequence, right? So we know that the general term, our general term is Tn equals to A R minus 1, right? And we know that our A is our first term. In this case, it will be negative 6, right? Then R is our common ratio, which can be calculated as the second term divided by the first term. So that will give us 12 divided by negative 6. So we'll have negative 2. Alright, so now we know our first term and the common ratio. Therefore, the general term for this sequence is going to be Tn equals to A, our A is negative 6, and then our common ratio is negative 2, and then that will be n minus 1, right? And now that we have our general term for the sequence, we can find our fifth term. So our fifth term is going to be minus 6 minus 2. So that will be 5 minus 1, which will result in negative 6 minus 2. That will be 5 minus 1, that's 4. So we're going to have minus 6 multiplied by 16, which will give you negative 96, right? And then we have the eighth term, which will be negative 6 multiplied by negative 2. That will be 8 minus 1. So we have negative 6 by negative 2 to the power of 7, right? So you're going to have negative 6 multiplied by negative 128, of which will give us positive 668, right? So this is because we have a negative by negative, so we're going to have positive 768. All right, now that we're done with question 4, let's go to the next question. So the next question is question 5, right? So it reads, determine how many terms there are in the following sequence, right? Which is 1 over 2, then 1 over 4, 1 over 8, up until we have 1 over 1024, right? So just before I continue, please pause and have an attempt at this question. When you're sure of your answer, you can then come back and see how it's actually answered or approached. All right. So first thing first, we need to determine the general equation, the general formula for the sequence, right? So we're gonna have Tn being equals to A R n minus 1, right? So we know that our A in this case is gonna be 1 over 2, and we need to determine our common ratio. So in this case, we're gonna have the second term divided by the first term, right? So we're going to have the second term, which is 1 over 4 divided by 1 over 2, right? So you know this is the same as 1 over 4 multiplied by 2 over 1, which is going to be 2 goes here once and it goes here twice. So this is the same as 1 over, the same as 1 over 2. So that's our common ratio. All right. So now that we have that, we can determine therefore our general term equation for the sequence, which is going to be Tn equals to A, which is going to be half, and then our common ratio is also half, and then we're going to have n minus 1, right? So we know that the last term is 1024, right? So now we actually need to solve for n, right? So we need to solve for this. We need to solve for this n here. All right. So let's go. So we have 1024, 1 over 1024, right? Equals to 1 over 2 divided by 1 over 2 and minus 1, right? So we proceed this side. We're gonna have 1 over 2 and minus 1. It's going to be, can do this, you can see 1 over 1024, all of this divided by half. So we halved in both the right and the left equation. So we're going to have 1 over 2 and minus 1. So we're going to have 1024, and this is 2 over 1. So we have 1 over 2 and minus 1. So that's 2 over 1024, right? So note this is going to be 1 over 2 and minus 1. So it goes here once. Half of 1024 would give us 516. 512, sorry. Alright. So now our final answer would be, let's proceed from this side. So we know that 1 over 2, is 1 over 2 n minus 1 is the same as actually 1 over 2 to the power of 9, right? So we have the same basis, right? Which means we can then equate our exponents. So n minus 1 equals to 9. Therefore, n equals to 9 plus 1, which will give us 10. Therefore, in actual fact, we have, in the sequence, we have 10 terms. There are 10 terms in the sequence. Alright, now that we're done with question 5, let's go to the next question. So our next question is question 6, and it reads, find the first 3 terms of a geometric sequence with the 4th term equal to 28 and the 8th term equal to 448. Right, so pause the video and have an attempt at this question, and when you're sure, you can come back and proceed with the video. Alright, so let's get started. First thing first, we know that our 4th term equal to 28. So from our general term equation, we know that what we have is Tn equals to a r n minus 1, right? And so they're saying that our 4th terms, this will be T4 equals to a r, and we know that our n is 4, so this will be 4 minus 1, right? So our T4 equals to a r to the power of 3, right? So therefore T4, which equals to 28, would be 28 equals to AR3. Right, fine. So let's go to the other statement. It says the 8th term equals to 448. So we have T8, and this will be AR8 minus 1. So we're going to have AR to the power of 7, right? And we know that our 8th term equals to 448. So we have 448 being equals to AR7, right? So we have 2 unknowns and 2 equations. And what do we do when we have that? We solve simultaneously, right? Right, so let's go. We have 28 equals to AR3. So we can say 28 equals to AR3, right? So we can make A the subject of the formula. So we can have A equals to 28 divided by R3. So this will be the first equation, right? Let's proceed from that side. So we're gonna have the second equation being 448 equals to AR7, right? And so now this will be our second equation. So we're gonna solve simultaneously by the method of substitution, right? So we're gonna substitute. So substitute equation 1 into 2, right? So we're gonna have 448, and then our A would be 28 divided by R3 multiplied by R7, right? So we're gonna have 48 being equals to, so this will be, this is the same as 28 So this is the same as 28 R7 divided by R3, right? And then we have 448 equals to 28. So since they're dividing each other, so we know that the exponents we're gonna find the difference of the exponent. So it's 7 minus 3. So we have 448 equals to 28. Then 7 minus 3, that will give you 4, right? So from this, we can solve for R4, which will give us R. Yeah, so that's R to the power of 4. So let's solve for R, which is our common ratio, right? So we're going to have R to the power of 4. Okay, let's just rewrite it here, firstly. So we're going to have 448 being equals to 28 R to the power of 4. So R to the power of 4 equals to 448 divided by 28. So this will give us R to the power of 4 equals to, this is going to give us 16, right? So we then know that R to the power of 4, so this is the same as 2 to the power of 4. So our exponents are the same, therefore our base is actually 2. So R equals to 2, right? And so now what we're going to have, we know our R equals to 2. Let's find our A. So previously we know that A equals to 28 divided by R to the power of 3, right? So A is going to be 28 divided by R, that's 2 to the power of 3, right? So that is 28 divided by 2 to the power of 3, that will give you 8. So 28 divided by 8. So 28 divided by 8, that will give you 7 over 2. Right, so we know A and then we also know R. So our general formula is actually Tn. It's going to be Tn equals to A. Our A is 7 over 2. So we have 7 over 2. Then our R is 2. So it's 2n minus 1. Right? So we need to find the first three terms. So T1 is going to be 7 over 2, 2. Then we're going to have T1 is going to be 1 minus 1 here. So we're going to have 7 over 2. And we know 2 to the, so this is 2 to the power of 0, right? So 2 to the power of 0 is 1, right? So 7 over 2 multiplied by 1 will give us 7 over 2, right? So anyway, A is equals to the first term. So yes. So let's go to the second term. Second term is going to be 7 over 2. And then we have 2, yeah, and 2 minus 1. So we have 7 over 2 equals to 2 minus 1, that's 1, yeah. So we basically have 7 over 2 multiplied by 2, which would be, so 2 cancels 2, that will be 7. And then t to the power of 3, we're going to have 7 over 2. So this will be 2 to the power of 3, 3 minus 1. So we have 7 over 2, and then 3 minus 1, that's 2, 2, 3, 4. So you basically have 7 over 2 multiplied by 4, right? 2 getting here once, getting here twice. So you have 7 multiplied by 2, which will give you 14. So we therefore know that our first terms is going to be, so the sequence is going to be 7 over 2, then we're going to have 7, then followed by 14, and so on. So that's our final answer. Alright, now that we're done with question 6, let's go to the next question. So the next question is question 7a, and it reads, if x minus 6, x and x plus 8 form a geometric sequence, find x. Right, so before proceeding with this video, just pause and have an attempt at this question, and when you're sure of your answer, you can come back and see how the question is actually approached. Alright, let's proceed. So first thing first, the best way to look at this question is to look at these terms, x minus 6, x and x plus 8, as the first three terms, right? So your x minus 6 will be t1, and x will be t2, and x plus 8 will be t3, which is your first, second, and third term, right? And we also know that this is a geometric sequence. So we know that for a geometric sequence, the following equation holds, which is x, which is going to be t3 divided by t2 equals to t2 divided by t1, right? So now we know that t3, that's your x plus 8 divided by your t2, which is x, and here it's also x, and then our first term, that's x minus 6. So we apply a cross multiplication here. So we apply cross multiplication, and then we end up with x squared. Then we have x plus 8 multiplied by x minus 6. So x squared equals to x squared minus 6x plus 8x, 8 minus 8 multiplied by negative 6, that will give us negative 48, right? And if we take everything to the left, we're going to have x squared minus x squared, positive 6x, negative 8x, then positive 48 equals to 0. Let's proceed on this side. This will result in x squared minus x squared. That will give us 0. And then 6x minus 8x. That will give us minus 2x. And then plus 48 equals to 0. And this will be negative 2x. Take 48 to the other side. Negative 48. Therefore, x equals to negative 48 divided by negative 2, of which will give us positive 24. So x equals to 24. Alright, now that we're done with question 7a, let's proceed to question 7b. So question 7b reads, if x minus 6, x and x plus 8 form a geometric sequence, find the first three terms of the sequence in numerical form. Alright, so you can have an attempt at the question, and when you're sure of your answer, you can then come back and see how it is actually approached. Alright, let's go ahead. And so now, what we do know is that x equals to 24, right? And then we know that our first term is x minus 6. So x is 24 minus 6, which will give us 18. Then our second term is x itself. So that will give us 24. And our third term, just write it properly. Our third term equals to x plus 8. So that will be 24 plus 8, which will give you 32, right? So the first three terms are 18, 24, and 32, and so on. Alright, now that we are done with question 7b, let's go to the next and final question. So our next question is 7c, which reads, if x minus 6, x and x plus 8 form a geometric sequence, find the general term, right? So we already know our sequence. We just refer here. You know it's 18, 24, and 32. So it's 18, 24, 32, and so on, right? And we also know our general term equation, right, which is going to be Tn equals to Arn minus 1, right? And so now we know that A, which is our first term, is going to be 18. So now we need to find our common ratio, which is going to be T2 divided by T1, right? So our common ratio is 24 divided by 18. And we know the highest common factor here is 6. So 6 into 24, that's 4. And 6 into 18, that's 3. So our common ratio is 4 over 3, right? Therefore, our general term is Tn equals to A, which is 18. And our common ratio is 4 over 3 and minus 1. So our general term is as follows.
Don't forget to subscribe.